Right. Hello, everybody. I think we're going to get started and we'll assume that people will trickle in. As a reminder, Daniel-Green Empowerment on our team is available if you have any questions, and you can chat him through the chat function. You should be seeing slides now, so if you aren't, reach out to him. We are really excited to have so many people join this webinar tonight and really appreciate folks joining from many different time zones, including our own team. My name is Andrea Johnson, and I'm the Executive Director of Green Empowerment, and really excited to be here tonight. It's one of the benefits of moving to a virtual world is that webinars like this can get such wide attendance, and it's a great example of kind of taking advantage of the opportunity that challenges may present, which is a classic Green Empowerment approach. So today we have a brief agenda that we are going to be walking through with you all. I will give an introduction to Green Empowerment and why we're so excited about this project for those of you who are newer to the organization. And then our team will be walking through the project, and then we'll present for about 30 minutes and leave the majority of the rest of the time for questions and discussion. So after 30 minutes, we will open that up, and if you have a question, we will ask that you put it into the chat box, and we'll remind folks of that. Some of our team members will be reviewing and moderating that and kind of taking questions as they come. So if you have a question during the presentation, we encourage you to write it down so you don't forget, and it may be answered later on. Also, we are recording this webinar today, and we will make it available, but we also want folks to know we are recording the webinar, and additional information about the initiative is available on our website, including frequently asked questions. Today, we are going to be joined by a few Green Empowerment speakers I just want to highlight. First, Gabriel Wynn. He's our Asia Regional Advisor. He's been with Green Empowerment now for over 10 years, based in Southeast Asia, and has helped work with local partners, primarily in Malaysia and Borneo, to install microgrids. Most of those are powered by microhydro. Some of them are microhydro solar hybrid systems, and some solar systems. So he's really going to share kind of why this project is so important to us, and has really, great deep field experience in understanding the context for this work. He's joining us from his home island of Bali, Indonesia. Then we're going to hear from Dan Friedman. He's our project engineer supporting this project since its inception. He's an electrical engineer who will really be diving into the technical details. So if that's what you're excited about today, Dan is your guy, and he is just really great at explaining some of these technical things in a way that's easy to understand. He's been based with us in Malaysia and the Philippines over the last few years, currently calling in from the UK in the middle of the night. We appreciate that, Dan, where he's based due to COVID restrictions. Micah Miro is also on the call. She's our engagement manager. She's leading the fundraising campaign and helping us make sure that we connect all the dots internally, as well as with industry professionals like many of you on the call, to make sure that this project is successful and has impact beyond even what we might imagine today. And then Daniel, who I mentioned, is our cross-organizational program coordinator, behind the scenes support across all of our projects, and also supporting on today's webinar. So Green Empowerment got started in 1997, and since then we've helped over 400,000 people gain access to renewable energy and clean water in rural communities across the globe. Fundamental to how we do our work is through partnership. We really believe that local leaders and local organizations are best suited to do this work. They often just may lack technical access, fundraising access, and project support. And that's really where Green Empowerment comes in. In addition to supporting these individual projects with partners, we also support regional networks and stakeholders in promoting best practices, training, and advancing technology innovation, which is where today's project is really focused. Currently, we have projects in communities in 5 countries in Latin America and 3 in Southeast Asia, and also are working on doing some expansion into Uganda, supporting renewable energy on health clinics. Some of that work was happening before COVID, and some is in direct response. So before I hand it over, I really wanted to just share why this is so exciting for Green Empowerment. And I want to start off with our legacy. So even though we've been around since 1997, our organization's actually built off the legacy of Benjamin Linder. He was an engineer from Portland, Oregon, who was in Nicaragua in the 1980s and was killed by US-funded Contras while working on microhydro projects in really small rural communities in northern Nicaragua. Some of these projects that he was working on still resonate today for us, and I wanted to share just a few things about those first few projects that really help set the stage for why this project is so exciting. So in one of the projects in El Chata, in the northern part of Nicaragua and El Cuá region, the powerhouse for the microhydro microgrid system was actually manually managed. So if you can, for those of you who are more tech savvy, and even if you aren't, just think about the organization and the community engagement needed to manage your electricity access manually. So our organizations and our partners have come so far from those days where you actually had somebody sitting in a powerhouse on rotating shifts, managing the energy production and the load. Today, you're going to hear about some of that load management and how we've come so far and how there's more work to do in thinking about smart grid and technology innovation in these same types of rural communities. But what's so exciting for me and what impresses me so much about these first projects that's carried us on is the community engagement. The amount of organizing, training, and ownership that it requires to really build these projects and have them be sustained over time. All of this technology innovation that we're working on is also to improve and better that community engagement and ownership. And second, because this is near and dear to my heart, one of those first powerhouse operators was a woman, Hilda, from the local community, who originally told Ben that she couldn't do it. Ben convinced her that she could, taught her how to do it, and she now still works with one of our local partner organizations in Nicaragua to this day. So these values of inclusion, community engagement are foundational to our organization's success over the years, and they're really woven in to all of the projects we do, including this technology innovation we're going to hear from today. So without further ado, it's my pleasure to hand this over to Gabe, who's going to dive into this project.
Thanks, Andrea. Hello, everyone. Can you hear me okay? Okay, so if you know us, most of you know us for the systems we work on with our partners in the field, but the main reason we're involved in a lot of these projects is to help our partners push the envelope for what is possible and for innovation and constantly improving the way that we as a community of practitioners engage with rural development. It's also because we know that these systems can be implemented more efficiently, reliably, and affordably by local organizations. So the goal is to constantly build local capacity to deliver clean energy systems from A to Z, including supporting local manufacturing and innovation where possible. So for those of you who don't know, Green Empowerment also provides access to toolkits, design templates, and operation manuals on our website covering a range of appropriate technology topics, including potable water systems, filtration, and feasibility study methods. So if you're interested in those, go ahead and take a look at the technology section on our website. More recently, we've been involved with supporting the development of an electronic load controller, which we'll describe in a little bit of detail here shortly, spearheaded by Dan Friedman, who you will also hear about after me. So with the microhydro systems, I guess just to quickly describe what a microhydro system is, for those of you who don't know, it works by essentially diverting a small portion of stream flow down a drop through a canal or a pipeline. The kinetic energy of this water is captured and converted to electricity by a turbine. So to work safely, these systems need a control system to direct required power to the consumer. And basically dump unused power in what is called a ballast, which is typically a large heating coil. Because microhydro systems typically don't include batteries, the waste energy needs to be spent somewhere. So controlling this is the most basic function of what we call the electronic load controller, or the ELC. ELCs are normally purchased from commercial entities outside of the countries where our systems are being deployed at considerable cost. So this presents two problems to practitioners. First, there's a lack of local capacity to fix these problems, fix problems when they inevitably arise. The second is the expense associated with purchasing and importing such products for systems that already often enough have to be completed on shoestring budgets. I'll just take a moment to tell you about the partners that we've been working with and will continue to be kind of hosting the continued development of this technology. I was still living in a village in Sabah in Malaysian Borneo with Tony Bung when we started looking at the problem of ELCs, but I've spent a fair bit of time with CBOT in the Philippines as well, and they perform similar roles. There are local organizations implementing clean energy systems benefiting the rural poor in Malaysia and the Philippines, respectively. So at this time, I should add, we had some of our imported ELCs being destroyed by little lizards getting into them and chewing through the power cables. And like, you know, even having ELCs was kind of a luxury for a lot of systems at this time. Some systems, as Andrea mentioned, were controlled manually by operators who slept inside the powerhouse, who would have to regulate the flow as people turned on new appliances and turned off appliances, and as the water flow fluctuated. Also not listed here, by the way, is but was a really key organization in allowing Dan to be here and for this work to happen, was the UK chapter of Engineers Without Borders, who sent Dan and some of his predecessors to Malaysia and to the Philippines as placement volunteers to work on the issue of microhydro load control. HPNet was very much the bedrock for a lot of this work as well. As you can see, HPNet is a network in the global south that connects microhydro practitioners to each other and creates a bit of a platform for us to exchange knowledge and technology. You can take a moment to see how these events happened, but I should acknowledge the amount of work that really went into this prior to and in between the events described on this timeline. You know, a lot of grueling, unpaid and underpaid work got us to this point from both our partners and volunteers, including Dan himself. It wasn't until late 2018 that any formal funding came through to support this work. And that was done through the Wuppertal Institute, or WISIONS. Some of you might know them. I hope they're on the call today. Next slide. I think you know, a lot of people ask the question, what is open source? And, you know, what's the reason why we're doing this through an open source platform? Basically, the term open source is used to refer to a piece of technology that anyone can modify and share because the design is non-proprietary and publicly available. So it originated, I mean, although it originated in the context of software development, it now designates like a kind of broader set of values and a way of doing things that is very practically suited to how innovation happens in the rural development context, right? Many of these innovations are not recognized because they're not happening in a lab at MIT or on Google campus. They're happening on like farms and small workshops and in the villages themselves. So, you know, open source projects or products can be developed by a community of like-minded professionals or just geeks who can really get into solving a problem together. And it allows for prototypes to be fielded a lot more rapidly and for people who are part of the community to adapt these designs to their local needs and contexts. So these are kind of the reasons why this is such an important methodology for proliferating the technology for us. I should add also that, you know, the way that innovation has happened in this field prior to there even being kind of a anybody labeling it as open source was kind of with this whole open source mindset. A lot of the turbine designs and drawings were kind of exchanged freely between practitioners within the network, and you know, even the founder of Tony Buongbani, Adrian Lasimbang, the original way he got into microhydro in the first place was through a microhydro Yahoo e-group, and his family was one of the first families in his village to have access to the internet, and you know, this kind of enabled a lot of this work to happen in the first place. So with the ELC now having been installed and tested in several villages, we began to think of the further needs and possibilities that could be addressed by the microcontroller platform, and began to see it as more of a building block than an end goal in and of itself. We started to look at issues like integrating remote monitoring systems, developing pay-as-you-go systems, managing appliances remotely, looking at non-hydro technologies, and even the potential of interconnecting previously isolated mini-grids to the larger national or regional grid. So this is the work we're trying to support right now. And so without further ado, I'd like to pass it over to Dan Friedman, who will tell you more about this work. Thank you.
Okay, thanks, Gabe. Hi everybody. Can you hear me all right? Cool. Yeah. In order to talk about the project that we're taking on, I'm just going to give a little bit of background on where the problem we're looking at comes from. So all electricity generation systems have a finite capacity. And to give an idea of scale, national grid utilities are typically gigawatt capacity, whereas the community-based renewable energy systems we work with are on the kilowatt scale. In an ideal world, your system capacity will always be sufficient to power as many appliances as you want. The extreme of that is to imagine plugging in every single electrical appliance you own at once. Now, if everyone did that who's supplied by the same grid as you, it would almost certainly cause a problem. I checked my kettle the other day, and I was quite surprised to see that it's rated at 3 kilowatts. We can see that it's a drop in the ocean for me to switch it on a national grid, but on a small system, it can be quite a significant proportion of the capacity. In fact, based on there being approximately 27 million households in the UK, if we all had 3 kilowatt kettles and switched them on at exactly the same time, even if they could respond to such a massive change in load so quickly, we would certainly be in danger of exceeding the installed capacity of the UK national grid, with an applied load of around 81 gigawatts. The more I think about it, with the estimated installed capacity of our national grid being suspiciously close to 80 gigawatts, it makes me wonder if they threw all the fancy models out of the window for estimating required capacity and simply calculated the maximum possible amount of people that could be making a cup of tea. In reality, it's next to impossible that that much load would be connected at exactly the same time. But we can see the relative size of any single appliance is going to have a significantly higher impact on smaller scale systems. And I know this sounds obvious, but it's important in showing that the need for load management is actually more critical on small capacity systems. What it boils down to, if you'll pardon the pun, is that it's important to forecast the expected demand, but compromises will undoubtedly have to be made. During system planning, it's important to consider the context we're working in. The indigenous communities that call these lands home are protecting some of the most biodiverse corners of our world, so it makes sense to support them and to do it with technology that has minimal impact on the ecosystems, watersheds, rivers, and wildlife. The organizations that work with and serve these communities are operating on very limited budgets, so cost is often a primary factor when planning systems, and any way to stretch budgets further is very gratefully received. This isn't directly related as such, but this image shows indigenous people in Ulu Papar in Sabah, Malaysia and Borneo, protesting proposals for a mega dam, which would submerge several villages, home to more than 3,000 people. Challenges like this are common for these types of communities and should be given greater visibility and scrutiny. Going back to electrical demand planning, thankfully for system planners, people don't connect all of their appliances at once, but this brings the problem of constantly varying demand. And on top of this, peak demand can still be significantly higher than off-peak demand, as most of us follow fairly similar daily routines. Predicting and catering for change in demand on national grids is tackled by teams of people and highly sophisticated automation systems. Implementing such controls on small-scale systems would be vastly costly, and also possibly like using a sledgehammer to crack an egg, especially when even finding salary for part-time operators is hard enough. So what can be done to handle high peaks in demand? Either you need to generate more power, you need to change social behaviors, or you need to have control over some of the loads connected to the grid. Similarly, increasing usage in off-peak times is desirable. For energy suppliers that may have invested heavily to build a system, they need to make back the money, and they need people to use the electricity to do that through tariff collections. In our situations, the community-owned systems are designed to pay back into themselves, i.e., tariff collection goes to the upkeep of the system. Some communities use fixed tariffs, but for those with energy meters installed, the more efficiently a system is utilized, the more revenue is generated to keep it operating and to maximize its service life. A standard system without load management might look like this. We have a plant with capacity of 10 kilowatts, but during off-peak times, consumers are only making use of 4. In microhydro systems with electronic load controllers, 6 kilowatts is diverted to the ballast load to maintain the electrical supply quality. During peak times, the consumer demand rises to 9 or 10 kilowatts, which is very close to the system capacity. If we think back to our kettle at this point, it would only take a few small appliances to be connected to cause an overload condition, triggering the safety systems. I wouldn't enjoy being the operator who has to get up in the middle of the night and walk along the edge of a terraced rice field with a sheer drop on one side in the pitch black to go and reconnect the circuit breaker a kilometer or two away in the powerhouse. Smart technologies for off-grid environments already use techniques for managing resources, but these can also be prohibitively expensive and difficult to maintain due to their proprietary nature. There are also options such as tariffs that change during peak times or timer switches, but making use of smart technologies becoming available at lower costs could bring a number of improvements in one package, particularly as an open source design that can be modified and customized. This brings us to our project, which involves taking some of the concepts used in more advanced systems and adapting them to our context. The technology we're hoping to develop can be divided into 2 main tasks. Firstly, the task of being able to send and receive data from the point of power generation, or powerhouse, to various points of consumption, which could be domestic households, community spaces, or small shops and businesses. The second task is to develop a scheme and accompanying hardware which uses knowledge of the live demand requirement, evaluates it against the available power, and decides which appliances should be allowed to operate. A system with load management could potentially look like this. Appliances are categorized into primary and secondary devices. During off-peak times, normal consumer demand is low, allowing the system to activate secondary loads. A few examples which are suggested here. This increases the use of available power for activities with social or economic value. When peak time comes around and consumer demand naturally increases, the management system could start to deactivate non-essential appliances, keeping the system operating and making sure an overload condition doesn't occur. This is an example applicable to microhydro systems, but you could also imagine load management being used to limit the depth of discharge in battery-backed solar systems. Imagine that you specify the batteries should only be discharged to 70%. When the batteries reach 75%, for example, only essential loads would be allowed until the sun comes up and starts charging them again. Or if the batteries are fully charged, extra loads could be allowed. Those familiar with solar systems will know that depth of discharge of batteries is critical in determining their useful operating life. Draining batteries even 10% more than intended can have a large impact on lifespan and will be factored into the system planning. Therefore, being able to control the charge-discharge cycle to a specified threshold could help ensure the system lasts as long as is intended. We plan to take on this project with the main objectives listed on this slide. Nailing down a way to facilitate the communication seems like an appropriate first step, because without this, no management can occur effectively. Following this, identification and analysis of one or more communities will take place in terms of their current electrical demand and their social and economic requirements. We will be working closely with our local partners Sibat and Tonibong throughout this project, so communities we study will be situated in the remote regions of Malaysia and Borneo in the Philippines. We will target communities in particular that are experiencing service interruptions during peak times or have large differences between their peak and off-peak demand requirements, and therefore low system utilization. This will lead into the development of a load management strategy based on the collected data and development of the hardware that can implement it. This will allow us to look at the cost of implementing load management systems on new or existing installations. If all goes to plan, we will then pilot the system in one of the communities we've studied to see if it does what it says on the tin. In summary, we hope that such a system could help achieve the following. Firstly, flattening the demand profile by decreasing the peak demand and increasing the off-peak demand. Secondly, allowing more appliances to operate successfully on small capacity systems. And finally, something we should get for free, logging of system parameters, providing insights into performance over lifespan, predicting maintenance requirements, planning of future systems, evaluating efficiency, and identifying faults. We hope this will ultimately bring the cost of systems down and stretch how much can be achieved with small capacity installations. To give a little technical insight into where we're going with this, for the communication side of things, we're looking at low power wide area network technologies such as LoRa, and also power line communication, which would take advantage of the existing electrical distribution lines. We need to be communicating over reasonably long distances, possibly up to 10 kilometers, where having line of sight is unlikely and could include dense forest and hills. In many villages, there is also a lack of cellular network coverage. It's important to keep in mind that every village will have different requirements, so multiple options might be useful. In terms of the management schemes, we'll be looking at how to group appliances and prioritize them, how interactions will be affected, and how appliances themselves are controlled. For example, would monitoring the temperature inside a fridge be useful to help determine its priority? We're also considering the implications of automatic control, most importantly in terms of safety, but also making sure we don't decrease the usefulness of the appliances. On top of this, there could also be potential for variable load appliances that might be suitable for thyristor control. These could run in some sort of eco mode if the available capacity is limited. I'm sure that other possibilities will present themselves as we move on with the project. Before I pass over to Micah, I just want to thank the organizations that got us this far with the ELC project, and without which none of this would have been possible. That's Engineers Without Borders UK, our local partners CBAT in the Philippines and Tonibung in Malaysia, Visions of Germany and the Hydro Empowerment Network, and of course everyone who's donating to help support our work moving forward, along with Efficiency for Access, which Micah is going to say a bit more about now, before we do some Q&A. Thanks.
Great, thank you, Dan. Hi, everybody, I'm Micah. I'm the engagement manager with Green Empirement. And I want to take a few minutes now to talk about the budget for this project and also how you can help. Can we see the next slide? Great. So we are really excited to share that Green Empowerment was recently awarded $69,000 US in a grant from Efficiency for Access, specifically from the Research and Development Fund. This grant is sized purposely to cover 70% of our projected budget for this project. And it is a stipulation of the grant that we raise the additional 30% matching funds. So can I see that next slide? One way that we are meeting this need to raise the additional funding is through a crowdfunding campaign that is actually active right now. We are aiming to raise $12,000 from people just like you who are professionals in the field and or are personally passionate about this kind of work. As an organization, we have found that this type of work, specifically research and development for technical projects, is a particularly hard kind of work to fund. It doesn't have the concrete promise of being able to say this many people are going to be able to have power once this project is installed. However, the benefits of this project actually have a much larger reach. Not only will this work make all of Green Empowerment's future microgrid projects more reliable and affordable, it also gives more control to local partners. And through making the resulting technology open source and available online to other microgrid installers around the world, this project has the potential to impact many more communities than we as Green Empowerment as one organization could ever directly interact with. So as you've already heard on the call, we are really passionate about this work. That's why we're holding this webinar to share, and it's also why we're asking for your help. Here are 3 ways that you can help this work move forward. So first and foremost, we hope that after you get off this call tonight, you will go to our crowdfunding page and donate an amount that you feel is meaningful and that will help us meet our goal. Please help us reach our goal of $12,000 by August 7th. You can see there on the screen, the URL for our crowdfunding campaign is on the screen there. You can take a moment now to take a screenshot of it or just a photo with your camera. Daniel has also put the URL in the chat box if you want to just click through from there or copy it over from there. In addition to donating, another way you can help is to share. So you can share this campaign with friends and colleagues that might be interested. That's really the way that crowdfunding works. You give what you can, and then you pass on the information, and the people you know give what they can, and little by little, we get the funding we need to realize this project. And finally, a third way you can help is through sponsorship. If you work for a company that might be interested, you can share this campaign with them and welcome them to sponsor a piece of the project. And with that, I am going to hand the reins back to Gabe, and he's going to open the floor for questions. Thanks, Gabe.
Yeah, thanks, Micah. So questions will be fielded in the Zoom chat box. I'm just going to read through and kind of ask them, and then I'll determine whether myself or Dan will be most appropriate to answer them, or both of us. So go ahead. Okay, so the first question is from Ayu. I think everybody can see it. I believe the open source initiative requires a thriving community to continue building and developing other than the organizations involved right now. How does Green Empowerment plan to build and support the community that will continue to develop and keep the devices going? That's a good question. I think I could start to reply to that, sort of. Basically, I mean, I think that the open source model, it's sort of kind of by definition supposed to be voluntary. Of course, we do have HPNet as well, and it's through the Micro Hydro Empowerment Network platform that we really want to be pushing this technology and be encouraging participation. We have held exchanges in the past through HPNet, one supporting specifically the development of the ELC. And this involved participants from a number of organizations throughout South and Southeast Asia that are working on microhydro systems. So I think we'd like to do that eventually, is also have like a kind of in-person exchange if we can get that funded. That would have more to do with the kind of more sophisticated aspects of load management and kind of some of the other tools that we would like to develop. But I think for now we're still at kind of the stage of what are the priorities for everybody, and how applicable are the tools that we're developing going to be to those other practitioners. Dan, do you want to chime in on this question?
I'd say you've probably mostly covered it. I mean, we're working with our local partners, obviously, but then having access to the Hydro Empowerment Network is really a valuable way to be able to get people interested in the work and see if they can benefit from it themselves. So yeah, I'd say that's probably one of the main ways that this technology is going to disseminate through the community of people who will be interested in using it.
Yeah, I should add also that, I mean, you know, Green Empowerment is also working on funded mini grid projects throughout the world, both in South America and in Asia. So you can bet that we'll be plugging this technology on those projects as well. Question from Ulysses Sherman. This distributed communication and control system sounds very complex. How does the cost and effectiveness of the ELC compare to load control by battery or pump storage, etc.? Thank you. Dan, do you want to take this one?
It's probably difficult to comment on the exact costs. Well, it's impossible to comment on the exact costs of it at the moment because we're still very early days. But looking at the way that the open source technology market is going in terms of all of the platforms like Arduino and Raspberry Pi and all of the associated devices that can be used with those being pretty low cost already. I mean, the thing that you're paying for with proprietary systems is normally like the IP, right? And the fact that you're spending money on development time. Whereas if you're willing to spend some time on it yourself and learn about these things and use information which is freely available, then you're kind of able to trade some of the costs of buying proprietary technology to for the time that you spend on developing it yourself. So pumped storage, I mean, I think the infrastructure of implementing a system like that is going to be vastly more costly than deploying some small like electronic networking devices which can actually handle the load management. Controlled by battery, I'm not sure about, to be honest. Do you mean to charge the batteries, I presume? Like a battery charging system. Yeah, I think. Yeah, I would say that if we're just implementing like a network of small electronic devices, then we'll sort of gain back some cost by using intelligence rather than infrastructure, costly infrastructure. Hopefully that answers the question.
Yep. Okay, we'll move to the next one here. From Narasimha Kumar, a technology question. How would power line communications work when the power is not well regulated? How would the devices be programmed as primary versus secondary? Dan.
Yeah. When you say not well regulated, are you talking about harmonic distortion on the lines, or?
Yeah, I think so.
Yeah, that's true. It's fluctuating voltage. You know, you cannot easily. In my thinking, you know, I may be wrong. In my thinking, you cannot easily modulate the signal. You know, the AC signal to send a message across potentially.
If the system is operating using an ELC, then that's the situation where you probably have the most harmonic distortion. By minimizing the size of the ballast load you're using, you can reduce that. And I'll hold my hands up and say, look, we haven't tried this yet, so I don't know how well it is going to go. But maybe we can use repeaters systems to sort of boost the signal. Mm-hmm. Or if that's not feasible, then maybe a wireless solution is going to be more suitable. So we'll have to see. And in terms of programming devices as primary or secondary, then the way the system I think is going to go at the moment is that we'd have sort of an appliance unit and a control unit which is based in the powerhouse, and the appliance unit will be fitted to the secondary loads, and those are the ones that will be managed, whereas the primary ones will just be managed by the consumers themselves directly. But again, that's another thing that we'll iron out as the project goes along.
Okay, thanks.
No problem.
Yeah, so there was also a pretty common question, which was, do we have manuals on the technical materials for the ELC? The answer is yes. They can be found. I linked the wiki on one of my slides, but it's just www.elcwiki.info. So you can find all the files there. Next question, how do you ensure that the project, this is from Omar AJ Saho, sorry, by the way, to anyone if I'm mispronouncing your name. How do you ensure that the project becomes a pro-poor initiative by supporting local communities and having access to affordable energy? How will the project go about in having both the local area government and community buy-in into the project? Does Green Empowerment or the local partners have any plans for the scalability and sustainability of the project to other communities and countries in the future? So I guess I can take this one. I can take a stab at this one. I guess it's 3 questions, but I'll try and answer them first. So basically, I think a lot of it comes with the model, right? I mean, the open source model we chose because you know, Green Empowerment's scale of impact is limited by our own reach geographically and our own capacity in terms of staff and our funding, right? So by supporting an initiative like this, we're able to really distribute the ability to work with this technology freely to anybody else who might have the resources to do it. Of course, if you're talking about local communities in the countries that we work, we're actively engaged in trying to support them to meet the needs in other ways beyond just with the ELC. But I think the reason, another key point of open source is the timing, right? So right now, even in a lot of the countries that we work in, you've got all of these kind of maker spaces and hacker spaces coming up. There's a lot much higher digital literacy than you might expect, even in some of the rural communities. So we really hope for this to be done in a participatory way, and because it's non-proprietary, and that sometimes, you know, the people who can access these technologies are not necessarily on the higher rungs of the socioeconomic ladder, that they can actually implement these systems themselves with just parts that they can find lying around or buy very cheaply from local hardware stores. So in terms of the project getting government and community buy-in, I think community buy-in is something that our partners are predominantly concerned with. They have their own strategies about that. I think, you know, this is not something we need to get to on this call specifically. But in terms of the government, I guess, yeah, I mean, ideally we have government supporting this kind of stuff. I know in Malaysia, the government is actively supporting establishing some of these like maker spaces, even in rural areas. And we'll continue to try and advocate for that. And as far as scalability and sustainability of the project to other communities and countries, I mean, this is what you're supporting, right? Like, this is why we're having this webinar. This is why we need funding to continue this project, is to expand the reach and expand the ability to do this. I hope that answers your question. Dan, did you want to add anything?
No, again, you've covered it, I think.
This is Andrea. I would just add that there are, you know, off-the-shelf solutions for some of what we're talking about here, but something that really helped put this in perspective for me was when I believe it was Gabe was telling me a story of a community that had spent years building their microgrid. The, you know, electronic load controllers and a key part of that. They invest in it. It has to be imported. Then you go upstream, maybe 8 hours in a canoe to go install the system. And when that technology piece goes down, the system goes down. And so for me, that resonated with me from a non-technology expert perspective, that having these things also be able to be fixed locally, not just built originally locally, is also a key part of that system being able to be maintained so that there is access. And so when a component goes down, the whole system isn't abandoned. It's actually able to be fixed locally as well.
Yep. Thanks, Andrea. For Dan, what is the maximum design electrical load these controllers can take?
The ELC that we've been working on currently, the largest models that we've built are on 24 kilowatt capacity systems. Our partners, Seabat and Tony Bong, are currently building slightly larger ones, just upwards of 30 kilowatts at the moment, but we haven't deployed any of those yet. No reason to believe that there'll be any problem at the moment, and also reasonably confident that you could go significantly higher than that, but we haven't actually tried it. So feel free to try it and let us know.
Yeah, that's also actually the answer for a lot of the questions here. I mean, this is supposed to be a trial and error thing. You know, you like the idea of open source is that you can go and try it out and have it blow up in your face if need be. And if you can try it yourself and are interested in doing it, you should. So
taking the proper safety precautions, of course.
Yeah, of course, right. From Chris Wiacek in Indonesia, I don't know how do you pronounce that, but apologies if you covered this and I missed it. Are you targeting microhydro as your prime energy asset for this initial application? Do you expect to encounter other energy generation or storage assets that will need to be integrated into this platform in the near term? I'd like to use this opportunity to really differentiate between the ELC, which was what I kind of spent a lot of my presentation talking about, and the kind of load management platform that Dan has been talking about throughout his presentation, as well as also mentioning some functions of the ELC. So the ELC project, while I wouldn't say it's completed and it's going to continue to be worked on, it is something that is targeted for microhydro specifically, right? The conditions where you're implementing hydro systems necessitate the existence of an ELC, and those conditions are not necessarily there for solar systems or other technologies. But for the load management platform and the remote monitoring features and the pay-as-you-go and those kinds of features that we've been talking about later in the presentation, those are absolutely applicable outside of the microhydro context. And we very much intend to test those applications throughout the course of this project. Anything to add, Dan?
No, not really. I mean, yeah, we mentioned that there could be an application of particularly solar, controlling how thoroughly batteries are discharged being a pretty important factor in solar systems. So whenever we sort of see a need where load management might be a benefit in terms of controlling how the system is used, then we can try and apply it to that. And because we are developing the technology ourselves, then we're kind of in a very good position to be able to, if we've got sort of 80% of it, which is universal to all of the applications, then developing the remaining 20%, which is sort of suitable to individual technologies, is a much smaller step than starting from scratch each time.
Yeah, and we also, should add that we've worked on a number of hybrid systems. I mean, just because microhydro is not always available everywhere as a resource that'll meet the needs of all community members. You have many scenarios where because a river is too small or because dry season flow is limited, hybrid systems are a lot more practical. You have a lot of diesel PV hybrids are also very, very common. So that's kind of, we're looking at a lot of those applications as well. Question from Ashish Dankar. Why are we trying to hit two birds at the same time, i.e. load management and ELC? Any specific reason for this approach instead of doing them separately and linking them at a later stage? I kind of feel like I answered that question, right? I see some nods, yeah? If you feel unsatisfied with that, send us another message. From Michelle Mapu, will slide set and recording be available to the public? I'd like to try and rope in some friends and wasn't able to do it yet. Yes, maybe Andrea or Daniel?
Micah?
Yep, we're recording, so it should be available tomorrow. Plan.
Okay, great. Yeah, we will make the slide set might not be ready by tomorrow, but yeah, we'll make the slide set and the recording available to everyone who's on this call. And the recording will also be on YouTube, so available in general to view.
So I have a question from registration, no name here, but I'd love to hear more about the partnership structure and sustainability measures. Good question also. Basically, I mean, as we mentioned in the beginning, we've got Tony Bung and CBOT, who are our main partners, and this is because they're kind of long-term green empowerment partners. They're accessible to us because we're doing a lot of projects with them and have been doing a lot of projects with them throughout the year. So it presents an ideal kind of testing ground for some of these systems. And so that partnership structure has been kind of in establishment for a long while. These organizations also implement a lot of projects independently of green empowerment and have basically offered to kind of purchase ELCs from this program instead of buying the ELCs from their typical commercial providers. So that's kind of, that also answers the sustainability question a little bit as well. I think the sustainability question, I mean, in terms of the long-term financial sustainability of this program is a bit of a challenging one for us. I mean, and that's sort of where we'd like to get some more inputs from people who are kind of more invested in the tech space. For now, you know, we're getting grants to support this work from E4A, from from the crowdfunding page that Micah shared. But you know, the systems that our partners are installing, the current arrangement is that they're kind of, like I said, buying the ELCs from us, and that helps continue and support the continued sort of R&D for this initiative. So another question from Ashish. It's an FYI. A demand management was recently developed by a startup, and it is an open source platform, which might be interesting. The company name is Inensus GmbH. We'll check that out. Thank you. And I think that's it, right? I mean, am I missing any questions? Please send me a reminder if I missed something. Do my colleagues want to just chime in and add anything if I did?
No, I think that's good. I think, you know, this, thank you so much to Gabe and Dan for taking the time in different time zones to share. And thank you so much for everybody for listening today, participating. And thank you, Micah, for encouraging folks to share this with your networks and continue the support. As I mentioned early on, this is a big part of what Green Empowerment does, is supporting our partners and communities in technology innovation. So I just want to emphasize that this actually came from a need identified by partners and members of HPNet as a need in communities, you know, having challenges with load management. So we're excited to see kind of how this evolves and hoping to get some, you know, new systems or systems upgraded. So we have a lot of systems that we've worked on. So this will be focusing on system upgrades to use this technology. So just want to say thank you so much for joining. If folks have any follow-up questions, feel free to send an email to Gabe, I believe will be the person, and we'll put his information in the follow-up email that Micah sends with the slides. And additionally, just want to emphasize that this information is available on our website, greenempowerment.org, with FAQs and ways to get involved, and obviously the crowdfunding campaign. So thank you so much, and please stay tuned, maybe sign up for our newsletter so that you can stay apprised of this project and the many others that we're involved in. Thank you.